Hi students, it's Ms. Culver. Um, I am doing two separate videos for 3.3b and C, working problems out. This video is going to have 89 and 90 and 60 and 64. And then on another video, so I have 89, 90, 60, and 60, I will have 65 and 66. The reason is I have to draw them out and I don't want to, waste your time watching me, try to draw the problems. So there'll be two separate videos that you see. So I do wish we had gotten to this 89 and 90 together today, but that's okay that we're doing it here, and let me know if you have any questions on it. So for 89 and 90, it says S of t is the motion of a particle. They have particles a lot on the AP exam, meaning it's its distance from the origin. So if a particle is moving to the right, that would be considered a positive velocity. And if the particle is moving to the left of the origin as time goes by, then that would be considered a negative velocity. And they're asking us questions. So again, you'll see particle, they talk about particles 3 or 4 times on the exam. So with number 89, this is the distance or the motion equation they gave you. S of t equals 6t minus t squared. In other words, at a certain time, and time has to be greater than 0, if you put that time into the function, it will tell you where the particle is located in relation to the origin, as if t was the axis. Okay. The first thing they ask for is A. It says, I need to flip the page. Find the velocity function for the time greater than 0. Well, that is just simply the derivative of the position function, right? And so we are going to take the derivative of the position function, and that would be 6 minus 2t. So we took care of A, right? That is the velocity or the derivative of the position function. Now, the next thing they ask you is, what time is the particle moving in a positive direction? Again, that's when the first derivative or the velocity is positive. Okay. Then they ask you when the particle is moving in a negative direction. That would be when the derivative is negative. And then they ask you at what time when the particle changes direction. Well, what's going on there when a particle changes direction is what's going on when you change direction, right? So if I am going in a certain direction, moving forward, and then I change direction, at that moment I change direction, I either change from a positive velocity to a negative velocity or from a negative to a positive. So it must be at that moment that I changed position that my velocity was 0, right? That is the only way when you have a continuous function to go from a positive to a negative or a negative to a positive, you have got to go through 0. So notice what they've actually asked us is, where is this derivative 0? Where is it positive and where is it negative? Isn't that really a first derivative chart? Isn't that what they've asked us for to do, right? And so let's go ahead and do that, right? Let's go ahead and do that. Here's my interval. Let's take a look. My interval, let's see, time has to be greater than 0, right? And I need my critical points. Well, this function is never undefined, right? So I need some critical points, right? That would be where the derivative is undefined or equal to 0. So let's see, undefined, this is a line, it's defined everywhere. Where is this equal to 0? That would happen at 3. Equals 0 at a time of 3, right? And so we answered D. That would be at a time equals 3. And now I'll be able to break it into intervals since I know where the critical point is 0. Where is the derivative positive or negative? So you probably didn't recognize this as a first derivative chart problem, but it really is. And then so my only critical point was 3. So 0 to 3 and then 3 to infinity because it's time. And that is the domain that makes sense for time. Let's do a test value. Let's do a 1 and let's do a 4. And instead of the first derivative, I'll just put velocity. That's what we're checking for. When I put a 1 into the velocity function, I get a positive. When I put a 4 in, I get a negative. And now I'm able to answer B. When is the particle moving in a positive direction? That would be from 0 to 3. I'll go ahead and I'll put that right here. B would be a time from 0 to 3. There's C. When is the particle moving in a negative direction? That would be at a time greater than 3. Okay, so actually they were asking us everything about a first derivative chart. Let's answer the same questions for number 90. Here we go. On number 90, so it's just a new function. S of t equals t squared minus 7t plus 10. There we go. Okay, the velocity function would be 2t minus 7, right? So we want to know the critical points, right? That would be the critical points where this derivative is undefined. It is defined everywhere. Where is it equal to 0? That would be at 7/2, or 3.5 would be the time. There we go. So we just answered the derivative is 0 at 3.5 seconds. I think this is in. And so we just answered D. There. Now the derivative is positive or negative on, right, the sides, the left or the right of a time of 0. Let's set up our first derivative chart. An interval, our time starts at 0 and goes to 3.5. And then we start at 3.5 and our time goes to infinity. Our test value, how about 1 and 4? And now we're checking that derivative. We know where it's 0. Where is it positive and negative? When we put a 1 into the function, we get a negative. When we put a 4 in, we get a positive. We just answered B and D, right? So the particle B is moving in a positive direction from a time greater than 3.5. And the particle is moving in a negative direction for a time, I guess I can really just say less than 3.5, because we know logically speaking that it wouldn't go past 0, right? But we could put the 0 in there also. There we go. Hope that helped on 89 and 90. We'll see that a lot more. Let's look at number 60 and 64. In both of these graphs, what is graphed here is f, an actual function, and they ask you to graph the derivative graph. Let me just check again and make sure that I am doing that correctly. Yes, they wanted a derivative graph. So remember, the first thing I do is, I'm going to see if I can get us a little bit closer maybe. The first thing I do is I like to know where the derivative is 0 or undefined, right? I think I need to close the curtain a little bit. Where the derivative is 0 or undefined, because that's an important part. And then I can work around that point, just like I did here. I first found where the velocity was 0, and then I said, let me see what's going on, before and after that. Okay, so I'm going to draw the derivative graph here in purple. So here's the original graph, right? And again, not real happy with the angle. I guess we're good, aren't we? Okay, I'm kind of fussing over it. There we go. Okay, now, logically speaking here, because this is a line, the slope is constant, and it looks to me like it's a positive slope. Okay, so I believe when I record the derivative graph in purple that it is going to be a constant slope. For each x, I'm going to record the same y. Now, what is that then, right? So let's take a look here. I don't see anywhere where the derivative, where the slope of this graph is 0 or undefined, right? So I won't have an x-intercept. Let's take a look here. Each one of these marks is 1. So let me see if I can execute the slope. If I go over 1 and up 2, then the slope of this line, I think, is 2. So the slope is 2 in this picture. So that means for every x, the slope is 2. So what is my derivative graph? It is this horizontal line that goes across here, right? And that makes sense, you know, that the slope is remaining constant. And so for every x in this purple line, I've recorded a slope of 2. Okay, now number 64, same question, and it is a little harder. And here's why. Where is the derivative 0? I don't see that anywhere. In fact, what I see is that as I go left to right, that if I made tangent lines, that the slope is always positive. Here, right, if I drew little tangent lines, and I will, the slope it's slightly positive, but very near 0 on the left, right? And that's like a horizontal asymptote. So it's heading towards 0, but not hitting there. As I go to the right, my tangent lines are getting more positive. And in fact, that's what's going on. It's hard to say, because you haven't seen this before, what is going on at this point here. And what is actually going on is this right here, this slope is becoming so steep that it's nearly vertical right here where x is 0. So I know that's a little hard for you to see here. It's nearly vertical, okay? And so I do believe that the slope is undefined where x equals 0. They're trying to show you that the graph is going like vertical, okay? So undefined right here. Now, what do I do with that then? That means when the derivative is undefined, that I can't record a point, right? So that's kind of hard. So I actually am going to save x equals 0 for last, because I'm not sure how to not record a point, right? So to the left of where the slope is undefined, my slope is close to 0, but it's positive and it's becoming more and more positive. Okay, let's see if I can make that happen. And what is happening to the right of this undefined slope? Notice that the slope is very, very positive right here, right? Infinitely close, it's incredibly positive. And it always remains positive, but it is becoming less and less steep, approaching 0. Okay, so this is what I think is going on. I think on the left here, for these x's, I need to record points that are very close to 0. And as I go to the right, approaching x equals 0, I need to record y values that are positive and becoming more and more steep. So here's what I think. For these x's, I'm really close to 0. And as I get closer to x equals 0, I am recording y values that are more and more steep. And I'm not actually going to hit x equals 0 because it's undefined there. So I think what I have here is a vertical asymptote, right, as I approach x equals 0. Now, On the right of x equals 0, it starts out close to 0, very, very positive, and as I go to the right, flattens out to 0. So again, right here, just to the right of x equals 0, I'm going to start out with y values that are very positive. And as I go to the right, they are approaching 0. So notice that I was able to record positive slopes very close to 0, and then very positive slopes. I was able to record that the slope, the derivative, is undefined at x equals 0. Notice I don't have a point. And then to the right, very steep positive, remaining positive, becoming less steep, and I was able to draw that curve. So that takes a lot of practice though. And so I hope that helped you. I wish we had been able to do that together in class.